Okay, so this video is an introduction to the binomial distribution. So first of all, let's just recap on what binomial distribution means. So this is how we write a binomial distribution. So this is saying that a variable is distributed binomially with a number of trials of n and a probability of something happening p. So binomial will apply when 4 criteria are met. So this is a situation where there are 2 outcomes from an event. There's a fixed number of trials. There is a fixed probability of something happening each time this event happens, and each event is independent of the previous one. So it is the same probability every single time. So as long as those 4 criteria are met, we can use a binomial distribution to do some calculations. So that there implies that all those criteria are met. Okay, so we need to know this. We need to know the formula. So this is how it works, that the probability of an event happening a certain number of times is n over r, and that's written as a vector format, and that is another notation for writing NCR, and I'm going to use NCR in my examples because that's what appears on the calculator. Then the probability of it happening to the power of how many times you're checking for, and then the probability of it not happening, 1 minus the probability, to the power of the number of trials minus the number that we're checking for. Okay, so that's what that means. It looks a little bit more complicated than it is. So you'll see what I mean when we get on to an example. Okay, so let's dive into this example. So for each of the following situations, write out the binomial distribution using the notation above. So this is asking us to write in this form here. Calculate the probability using the formula. So we're going to do the calculation using that method, and then check your answer using the calculator. So I'm going to use my graphical calculator to do the calculation, which makes normally this formula not required. Okay, so let's have a think about this. So we need to read the context of the question very, very carefully and make sure that we turn this into a binomial problem. So a restaurant takes bookings for 20 tables on Saturday night. The probability that a party does not arrive for their booking is 0.15. Find the probability of that 2 parties do not arrive. Okay, so normally when you get a question of this type, it would say assume that it's binomially distributed, but I'm going to just kind of assume that this is expecting a binomial distribution. Okay, so let's do part A. So I want to write out the binomial distribution for the notation above. So I'm going to use a variable. We, by convention, use a capital letter. That symbol means is distributed. This means binomially, and you will be using other distributions as you work through the course. And then how many times are we doing this trial for? And the answer is 20, because we are checking against 20 different tables. The probability that the party does not arrive is 0.15. So that is what we are checking for. We want to know the probability that somebody does not arrive. So that is what we would write for part A. Okay. And that's all there is to it. Right, okay, so let's do part B. So I need to now check that the probability that 2 parties do not arrive. So actually what I'm checking for is the probability of these 20 tests, 2 of them are true. So that is what I'm trying to work out. Exactly 2. Okay, and I'm going to use the formula to do this. So I'm going to use NCR, so my number of trials is 20. C stands for combination. R is 2. The probability of this thing happening, which is the party not arriving, is 0.15 to the power of the number we're checking, times the probability of this thing not happening, which is 1 minus the probability. Don't forget there's only 2 things can happen here. The thing can either happen or it can't happen. So those 2 probabilities must add up to 1. To the power of the number of trials minus the number that we're checking. So that's 20 minus 2. And when we do this check, those 2 numbers will always add up to the number of trials, if that makes sense. Okay, now I'm going to type that into a calculator. And I am going to use my scientific calculator. And I'm going to show you in a second how you can do this on the graphical. But the reason I'm going to use the scientific calculator is because it is easier to find the NCR. So I'm sorry, this is not showing up very well, but the NCR is above the divide button on this scientific calculator. I know most people have this model, and it's just a little bit easier to deal with than on the graphical, and I'll show you on the graphical in a second. So I'm just going to type that into my graphical calculator. So I'm going to type 20. I'm going to do shift and divide to get my C. I'm going to type in my R. So that's my NCR. That's 20C2 multiplied by 0.15 to the power of 2 multiplied by 0.85 to the power of 18. Press equals, and I get 0.229 to 3 significant figures. Okay? Right, now part C then says check your answer using the calculator. Now what that is just asking me to do is to now go and do this the way that you will normally be doing this, which is on your graphical calculator. So I'm going to turn my graphical calculator on, and I'm going to go to stats mode. Okay. So we go to the function that says dist. I go to the function that says binomial, and I get 3 options. I've got BPD, BCD, and InfB. Okay. So when we are doing a calculation where this is an equal, so I'm trying to find the probability of a precise number of outcomes, I use BPD. Okay, we'll come on to BCD later. So it's the BPD that I want. Okay, there's a set of prompts, so we'll leave the variable as variable. The X is the number that I am checking for. Okay, so this is this 2 here. So type in the 2. The number of trials is the number of trials, which is the n, and the probability is the probability that we are using in our binomial distribution. Okay. Now, if everything has gone correctly, what I will get if I press exit is exactly the same calculation, exactly the same answer as I got on the previous one, and there we go, there it is, 0.229 to 3 sig fig. And when you're doing these types of calculations, it is perfectly acceptable within an exam to go straight from here to here. So this type of processing is not required, so you can go straight from here, unless of course it's specifically asked for. Okay, so what I want you to do now is to pause your video and to go and try the Now You Try and when you restart the video I will do the answer on the video. Okay, so pause now. Okay, so you've had a go at this now, you try, so let me just do this now for you. So a pupil attempts a multiple choice test. There's 30 questions and each question has 5 answers. The pupil has not done any revision, so they guess each question. What is the probability that they get exactly 8 questions correct? Okay, so let's do the first part of this, which is to write out the binomial distribution. So I'll use x as my variable, is distributed binomially. This time I am doing 30 trials. There are 30 questions. Each question has 5 answers and the pupil is guessing the answer. So the probability of getting something right, I think we will agree, is 0.2, 1 out of 5. Okay, so that's our solution to the first bit. What is the probability that they get exactly 8 questions correct? So this time I want to know my probability of x being equal to 8. So I'm going to do it the long way. So I want, using my formula, I need 30 C8, so that's my NCR, times 0.2 to the power of 8 times the probability of it not happening, so 1 minus 0.2, 0.8, to the power of this minus this, which is 22. So let's do that again, once again on the scientific calculator. It's perfectly okay to take 2 calculators into an examination. So let's see if I can get this and that on the screen. I'm not sure whether I can, but anyway, there we go. So I've got 30 C8 times 0.2 to the power of 8 times 0.8 to the power of 22. Press equals, I've got 0.111 to 3 significant figures. Okay, let's do that on the graphical calculator using the binomial function. So I'm going to go to binomial. I'm going to go to BPD because it's an equals. I've got my x is 8, I've got my number of trials is 30, and I've got my probability is 0.2. Hopefully I get the same answer as before, and there we go, 0.111 to 3 sig fig. Okay, so that is how to go about those.